Hi, everybody. Welcome. I'm always excited to do stuff with our community partners. And when I got asked to do a presentation on birds, I chose migration because I think it's one of the most amazing things that birds do. And we're learning more about it every day. So thanks for being here and going on this journey. I'm going to start just with one of the showstoppers of the bird migration world. This is the Arctic tern. It's a little seabird. It's about a foot long from the tip of its bill to the end of its tail. It weighs 4 ounces, so 1/4 of a pound. And this bird nests way up here. I don't have a pointer on this slide, but way up at the top of the slide there is the North Pole, and the bird nests pretty close to that and then spends the non-breeding season down towards the South Pole. So if this little 1/4 pound bird flew directly from one spot to the other, that would be about 20,000 miles or 44,000 kilometers, which is a pretty extraordinary journey back and forth for a bird that weighs 1/4 of a pound. And these are actually pretty long-lived seabirds. On average, they could live up to about 30 years. So they're successful, more successful than you could imagine making that journey, but they don't even fly that directly. They make this little figure-8 loop through the Atlantic Ocean, and they do that very cleverly because trade winds and prevailing winds will provide a boost to them so that that journey is actually easier. And that means that these birds are making a round-trip migration of 70,000 kilometers every single year, which is really quite amazing for a bird. And because they're that long-lived seabird, that is the equivalent of about 3 trips to the moon and back in their lifetime. So migration is amazing. This is the longest known migration of any bird that we know about, and it's a pretty well-studied bird. So after kicking that off, let's just look at what we'll talk about today. A little bit about the whats and whys and wheres and whens. We'll talk about how birds navigate, a hot topic of study in bird science, and then a little bit about how you can help these birds on their journeys. And then I'll finish up hopefully in about 35 or 40 minutes if I don't talk too long, and you all can ask some questions. All right, let's start at the beginning. What is migration? Pretty simple. It is a seasonal, twice-yearly movement in between 2 spatially distinct places. One of those places is typically where the birds breed, and the other one is where they spend the non-breeding season. It's different from other movements that birds make, right? It's different from their local foraging movements. It's also different from when a juvenile bird disperses away from a nest site. That's a one-way journey, but those can be connected. And this can be a long-distance flight, a shorter distance flight. This can go in many different directions. This can happen at different times. So many different strategies that birds use to migrate. But they don't all migrate, right? If the conditions are pretty good for food and weather all year round, some birds just stay put. So these are what we call resident or sedentary species. And they don't make that annual movement back and forth. The lifetime range of a sedentary bird can be pretty small. This is really common in the tropics, but it's also pretty common here where we live, right? The weather is nice. There's lots of food all year round. So most of our woodpeckers, most of our owls, some of our songbirds, some portions of some of our songbirds. We'll talk a little bit about partial migrants in a second. What else? A portion of our bald eagles are resident here. And that's an important concept because for most bird species, there are some populations that migrate and some populations that sit still. About 70% of the bird species in North America are migratory, but only some of the birds of that species are actually migrating, right? So like robins that breed way up north in Canada aren't going to spend the winter there. They're going to move a little bit, but many robins are just probably going to stay where they bred, depending on their breeding grounds and the conditions. Great blue herons live here. They have a lifetime range of maybe a few kilometers across, and they're a pretty long-lived bird too. So comparing that to 70,000 kilometers of the Arctic tern, it's pretty pretty good advantage if you are the bird that is resident, because you're already on territory, so you can set up your nest before all these other birds come in to set up their breeding territory. You can spend more time raising young. You can raise more clutches. You don't have to flap 70,000 kilometers to get where you're going. So there's definite advantages to birds that don't migrate. So if that's so great, why do birds migrate, right? This is a long, complicated evolutionary story. We think there's two main drivers. This is food supplies, or this is nesting resources, and those are very closely connected. If all of the birds gathering in the winter in the cozy confines of Costa Rica, or densely concentrated on Sauvie Island in the winter here, if they all stayed to raise their kids, they would quickly run out of room and they would run out of resources. So lots and lots of birds make the evolutionary choice to venture out into the temperate and tundra regions where space is really abundant. Food resources bloom in the summer. If you think about this, most of these breeding areas are at higher latitudes, so in the summer there's a lot more daylight, which means they have many more hours to forage. So those are the main drivers of migration. Less competition for space, less competition for food. And then these birds can also return to nice, cozy places like Mexico in the winter. It's really, really metabolically expensive to migrate. So there are some very big costs to that. There are predation risks along the way. There are chances that your stopover sites, your breeding site or your wintering site is going to be gone the next time you visit it because of habitat changes. So this is a perilous journey, but it is also a rewarding journey. We have found out that the breeding potential of migratory species overall is higher than with resident birds. So that's kind of cool. What triggers migration? Really oversimplifying here, but it's this cascade of hormones that gets set off by photoperiod. So days get longer or shorter in the fall, and that triggers this cascade of hormones that gives birds the urge to fatten up and then to move. And it's pretty fixed, right? With climate change, a lot of things can shift along the migratory path, but daylight stays the same. Climate shifts don't change the number of hours in the day. So this is a challenge for birds in an era of climate change, right? They might be doing better if they could get to an area a little bit early if it's experienced a big shift in climate. But since they're pretty hardwired to leave at exactly the same time every year, they're having a hard time adapting to changes brought on by the climate. Spring migration is in a big hurry. Birds really want to get to their breeding grounds as fast as they can so they can set up those territories, grab the best territories. Going back in the fall, it's pretty leisurely. Most of these birds are not in a big hurry to get back to their wintering grounds. And scientists have found a correspondingly decreased amount of these hormones in the fall as compared to the spring. So kind of cool to have that backed up by science. Little bit on distance. We use words like long distance migrant and short distance migrant, and those are pretty loose terms. But generally a long distance migrant is a bird that crosses hemispheres or really big barriers like giant deserts or giant seas. So these are a lot of the birds we think about that migrate from North America to South America, or birds from Europe to sub-Saharan Africa. These are long distance migrants. This cliff swallow up on the top breeds here, probably right here on campus during the summer, and then it flies all the way down to Central South America in the winter. And then short distance migrants, this might be a bird migrating 100 miles, maybe up to 1,000 miles, but generally on the same continent. And these are birds that have a little more flexibility in their migration timing. The sage thrasher is familiar if you've been to Malheur or anywhere out in eastern Oregon and seen these birds breeding out there. They're spending their winter in the border region around Arizona and Texas. So we would call those short distance migrants. Which way do they go? They go all kinds of directions. The most common way that most birds move is across latitudes. This is usually what we think about when we think about bird migration, is birds moving north and south. So birds tend to, again, move up to these higher latitudes where there's more daylight, more hours for foraging. Everything is quite replete with insects blooming in the summer. And then they move down to lower latitudes for the winter where the days are shorter. But there's also plenty of birds that move longitudinally, so they move east and west. This is actually more common in Europe because if you think of the way the continent is arrayed, it makes a little more sense that there's a little more east-west movement there. But a lot of our birds also migrate east to west. California gulls, ring-billed gulls are a good example. These birds breed in huge colonies at Malheur or Summer Lake or the Great Salt Lake, and then move to the coast or into the Portland area for winter. So if you go up to the Columbia Gorge today and you put out a lawn chair and sit there and watch migration, you might see big numbers of California gulls moving west downstream on the Columbia River right now. And then another really common strategy is to move up and down slope. So this is called altitudinal migration or moving across elevations. And a lot of birds do this in a kind of variety of ways. American dippers are an example of a bird that breed way up in the mountains and then spend the winter down at sea level mostly. Our yellow-rumped warblers and ruby-crowned kinglets that we're also excited to have here in the winter, they're going up in elevation to breed. They're probably also moving north, so there are combinations of these effects. Birds can both move up and they can move across. Sooty grouse are a pretty cool bird. They actually do this in reverse. They walk up slope in the winter and they spend the winter up high, subsisting on dug fir needles, and then walk back down for the breeding season. So birds can move in different directions and they can move at different times of day. So do birds fly during the day? Do they fly at night? Do they not care? Do they fly all the time? Yes, it depends entirely on the species of bird. And that depends a lot on the anatomy and physiology of the birds. We'll talk about that in a second. Their dietary needs, how far they're going. Let's start with diurnal migrants, or birds that fly during the day. So quite a few birds that do this. We're going to start with the larger, longer winged species, the vultures, most of our raptors, storks in other parts of the world, pelicans. These are all birds with what we call low wing loading. So big, long, broad wings that carry less weight relative to the size of their wings. So big wings, smaller bodies. And so these birds are really adept at soaring. And they soar most effectively on these rising columns of warm air called thermals, which of course only happen during the day. So this is part of the reason that these are diurnal birds. You've probably seen hawks circling upward on a warm day. What they are doing is banking a little bit to stay inside this column of rising air and get as high as they possibly can. And then when that column starts to dissipate, they turn in the direction they want to travel and they just soar out and they slowly lose altitude, and then they'll hit another thermal and they'll go up again. And in this way, raptors could migrate thousands of miles and barely flap if they have the right condition with that series of thermals, which is pretty cool. These are birds that are mostly going to forage before they fly or when they touch down, but there are some birds like the Swainson's hawk down on the bottom of the slide that actually switch their diet during migration. So when they're breeding, they're probably eating voles and mice and rabbits and all kinds of little rodents from the ground, but they will switch to an insect diet. Moths and grasshoppers, large flying beetles, dragonflies, so big insects that they can catch on the wing and spend less time foraging, and they can eat along the way more easily. So kind of a cool strategy for these birds. We have turkey vultures that migrate into our area. They start showing up about March, and they're usually out of here by about mid-October. These are birds that breed as far north as the central Canadian provinces, and then they winter as far south as southern Argentina. So that's a very, very long migration for these birds. They're a big, I think, beautiful bird, but it's a lot of energy to flap your wings if you are a turkey vulture, right? You're a very big bird. So these birds migrate almost entirely by gliding. They are really adept at using those thermals to move themselves across the continent. They often also migrate really high. They can be in the clouds, they can be above the clouds, they can actually reach altitudes of like 18,000 feet if they're escaping a storm, which is pretty amazing. So strangely, at Hawkwatch observation sites, turkey vultures are some of the harder birds to pick up sometimes because they are flying so high. In terms of diet, they are fasting a lot on migration. All of our New World vultures are capable of flying for a few days without eating, and turkey vultures certainly do that, and that's been confirmed by scientists who sit under roosts on migration. There's a big study in Panama, and watch these birds fly in and then figure out how much guano was left, and not too much on migration. And if you've ever been under a turkey vulture roost in eastern Oregon or anywhere else, you know that they are prolific poopers. So pretty amazing. They're also really emaciated when they get to their wintering grounds. These are all of these diurnal raptors that we're talking about, and vultures have to be mostly flying over land, right? Because that's where thermals exist. They don't emerge from the water. But turkey vultures can make short water crossings. They often move from Florida to the Caribbean islands, for instance. And so that's kind of a fun way to watch these birds on migration because they're nice and low at that point. All right, an entirely different group of birds that fly during the day, little guys, swallows and swifts, hummingbirds, kingbirds are all examples of diurnal birds. And they have kind of the opposite body style, right? They are small, they are super acrobatic, they are fast flyers, and so they are much better at escaping predators. But probably diet is the main reason that all of these species are daytime migrants. The swallows and swifts, of course, are relying on insect prey, and they need to kind of eat that constantly. They forage on the wing, and insect numbers are going to be much bigger during the daytime. So their food resource is just more abundant. Hummingbirds, similarly, they are relying on nectar flow as they move, and that is also a resource that is much more abundant during when things heat up. Nectar is flowing more freely. Very cool birds. We're going to talk about one of them that we have here, the rufous hummingbird. So these birds are migratory. They come up here, you might start getting these here as early as April, and most of them are gone now. The males got out of here in July, and the young and the females are starting to really move out, or finishing their moving out. 3 inches long. So tiny bird, 4 grams, that's 1/7 of an ounce, right? So that is much smaller than an Arctic tern. And they breed up as high as southern Alaska, and they winter kind of all through the country of Mexico. And that is a pretty long journey for a bird that small. It is, in fact, almost 4,000 miles each direction, which is a lot less than 70,000 kilometers, but it is 78 million body lengths that this bird is traveling twice a year, which is kind of amazing. And they do this kind of cool circular migration. You can look at this map up on top. They're wintering down in the blue area. In the spring, they start moving up the California coast in that green patch. And what they're doing is following the bloom. So just as things start to have nectar flow, they have their migration adapted to follow that nectar flow up. They will breed up in the red area, and then instead of going back down California where all those flowers have dried up in the summer, they choose a mountain route. So they will actually go down the Rocky Mountains to get back down to their wintering grounds. Okay, those are daytime flyers. What about nighttime flyers, there's a lot of benefits to flying at night. One of them is that you can escape a lot of predation if you're a little bird and you fly at night. Most of the predators on flying birds are other birds, right? Peregrine falcons or bird-eating hawks, and those are all daytime flyers. So if you fly at night, you can escape a lot of that predation. You can touch down and feed all day, actually, if you need to, which sometimes these birds do need to during migration, or you can feed heavily in the morning and rest at midday, and then feed a little more before you take off at night. The big advantage at night is the air is much cooler, right? And we've talked about that big metabolic lift of flapping your wings for thousands of miles. That generates a ton of heat. So in cooler air, birds can shed that heat way more efficiently. And then the air is also less turbulent. So birds can fly faster, they can fly farther, they can expend less energy flying through air that is calmer than air that is turbulent. And there are a lot of nocturnal migrants. So we just talked about 70% of our North American birds, at least portions of the species. I guess 70% of our North American bird species are migratory, let me say that. And about 80% of those migrate at night. And that includes most songbirds, which is surprising, I think, to a lot of folks. Not all of them, we just talked about swallows. But cuckoos, flycatchers, most thrushes, pretty much all the warblers, vireos, sparrows, these are all birds that are migrating at night. And if you think about these birds, unless you're seeing them on your feeder, you're not usually seeing them right out in the open, right? You're seeing them tucked into a tree or having a little bit of cover. They're a little more secretive of species than the diurnal migrants. They're a little less agile. And then when you get into the birds that are really not agile, like the American coot down there, these birds with real high wing loading, so short little wings on fat little bodies, these tend to be night migrants too. Most ducks are night migrants, and most shorebirds, most of the time, are night migrants. That cool air is really advantageous for a big, heavy-bodied duck, and that less turbulent air is really helpful for a shorebird that tends to have a long-distance migration path, and it wants to have an efficient way to get there. How fast do these nocturnal migrants fly? The long-distance birds tend to fly faster than the short-distance birds. So there was a big study of passerine or songbird nocturnal migrants that uncovered an average flight speed of about 38 miles an hour for the long-distance migrants and about 18 miles an hour for the short-distance migrants. This is an average flight speed. That's pretty impressive. That probably has something to do with the fact that the long-distance migrants are flying higher, and so they actually have less turbulent air, and they're probably going farther. That's just songbirds. Geese can fly easily 50 miles an hour for long distances on migration, and if they get a tailwind, they can go much, much faster than that. How far birds fly every night really varies depending on the species, but on average, a songbird can typically make about a 200-mile journey every night. And then how high do they fly? They fly higher during migration than at other times. That's kind of obvious, I guess. The typical migration altitude, this is for a bird called the reed warbler. This is a European species. Their typical migration is 2,000 meters, which is pretty high, right? That's well over a mile up. That's their average height that they are flying. And if they're escaping a storm, they've actually had geotagged reed warblers located at 6,000 meters high, which is very, very high indeed. They start flying, I think, kind of just after sunset. They will feed as long as they possibly can, fattening up for that big expenditure of calories. And then that migration usually, that taking off part of the migration usually peaks about 2 to 3 hours after sunset. And then they're flying all night, and then somewhere between 3 hours and sunrise, those birds are coming down again. So that's kind of the window of flight, and it's kind of fun to observe night migration, right? You can't see it, but you can hear it. You can hear a lot of it. And this is a really good time of year for that. September is kind of a famous month to go listen for Swainson's thrushes as they are flying out, because they're flying out in big numbers. I have a couple sound files in here. And it's kind of fun to go just pick a spot a little bit away from urban noise and put a lawn chair and a cup of tea and a blanket and just go do a sit spot at night. Here is the sound of the Swainson's thrush at night. A short, sweet note. It can become pretty easy to identify if you listen to it. Not a lot of other ambient noise around. Kind of a magical sound. And then these are greater white-fronted geese. So Swainson's thrush will start moving very soon here. And then towards the end of September, greater white-fronted geese are going to be moving in big numbers. This is sometimes described as the sound of geese laughing. They have these doubled up notes in the middle of all the other chatter. So different from what a Canada goose or a cackling goose sounds like, right? With that doubled up note. I really like to do this on a warm September night and listen for bats and crickets and leaves rustling. If you've ever done a sit spot during the day but never done one at night, highly recommended activity. Whoops. Okay, there we go. Okay, so we have birds flying during the day. We have birds flying at night. We have birds that are kind of flexible. Yeah?
I just wanted to ask a quick question about birds' eyesight for night migration. I never really thought about them having good eyesight at night, which maybe is ignorant, but...
We're going to get to this.
Okay.
Yeah. Okay, so flexibility. Some species have a preference, right? So those greater white-fronted geese usually are nocturnal migrants, and sandhill cranes usually are diurnal migrants, but you can hear either of those in the opposite time of day. And if you think about it, these are both species that have to set down somewhere that there is good food for them to eat. To fatten up during the day, right? So if a sandhill crane is flying to its next stopover site and it gets caught in some weather and slowed down, or where it thought it was going to land doesn't exist anymore, those birds just have to keep flying until they find the good place to set down. They're not just going to come down at dusk in the middle of the city, right? They need to find the right place to land. So some birds are flexible. You can have sandhill cranes flying well into the night if they need to. And then there are these ultra marathoners. This bird on the lower left is a bar-tailed godwit. These birds famously make a journey from their breeding grounds up in Alaska to their non-breeding territories in New Zealand over 9 days of continuous flight. They never stop, they never feed, they never land, they never do anything but fly 9 days continuously, which is amazing. You have to imagine how much extra mass those birds put on before they start that journey and how emaciated they are when they land. But that is their evolutionary story in terms of migration. Okay. How in the world do these birds do this? Is going to start getting to your question a little bit. I think the most important thing to think about when we're talking about the hows of navigation for birds is that it's probably never just one thing, right? There's a toolkit, and there are a lot of tools in that toolkit, and some of them are more important to certain species, and some of them are more important at certain times of year. But they're all amazing tools. We are learning a lot about them. I feel like migration science is a very hot topic in bird research right now. I'm going to have to oversimplify a lot of this, but we'll start with the compass and then move on to the map. So maybe you've heard that birds can sense the Earth's magnetic field before. This is true. Birds can do that, and that's a really amazing thing, right? We know the magnetic field is stronger at the poles, but it's also differentially strong across the Earth, depending on how thick the bedrock is. So if a bird can sense that magnetic force, it can gather a lot of information about where it is. And birds are doing that a couple of ways. They have a mineral in the upper mandible of their bill called magnetite, and that is a mineral that is sensitive to the Earth's magnetic field. So that's one way that they're gathering information. And then fairly recently, folks have discovered a pigment in birds' eyes called cryptochrome, a protein, in birds' eyes called cryptochrome. And through a whole lot of complicated physics, that cryptochrome, that protein, is interacting with light molecules and the Earth's magnetic field to create a visual pattern on the bird's retina. So they are actually able to see the magnetic field. So they are like looking at a compass, essentially, and a more complicated one than we have that just points due north. So very, very cool. This is a lot of research being done in the laboratory, right, where they will screw with a magnetic field and watch birds get really confused. It gets a little more high-tech than that, but that's how we're learning about birds' ability to navigate using the Earth's compass. If we eliminate that compass or we mess that compass up, the direction that birds move changes in a laboratory setting. Birds are also using the stars. You've maybe famously heard birds use star maps. They're not probably memorizing the constellations or naming them at all, right? They're probably using the apparent rotation of stars around the poles in order to orient themselves. So if we go out on a dark night in the northern hemisphere and look at the North Star and we look at it all night, all the other stars are going to look like they are rotating around that star. So they are using that apparent rotation of stars around the poles to orient themselves as they take off. They're also probably using the relative position of the setting sun throughout the years. That changes from day to day. And this is a pretty cool tool, and it's one that we as humans screw up more and more with a lot of artificial light pollution. So this is one of the conservation issues that we are really interested in as folks that want to protect migrating birds, is trying to reduce that artificial light pollution, because it confuses the signals that the birds are getting, and it draws birds into our overly lit cities and into a whole lot of hazards on the landscape. We'll talk more about that in a couple slides. All right, birds are probably also using vision. Probably diurnal birds are the birds really using vision most, though. These other tools are going to be more important for the nocturnal birds. Lots of birds have amazing vision. Very, very famously, raptors. They actually have a completely different construction in their eye that, I'm trying to figure out how to describe this. The detail that I could see at 20 meters with my eyes, a raptor could see that detail at 200 meters. They have this extra fovea in their eyes that just gives them this precision vision, sort of like a zoom lens. So definitely birds are using some visual clues. We think that shorebirds are probably keeping coastlines in sight as they migrate. Raptors are probably keeping different visual clues of the ridgelines that they're following in sight. The Mississippi River Valley, for instance, is a big visual clue that happens to hold a huge proportion of our migrating waterfowl in North America. They just follow that Mississippi River Valley, probably for multiple reasons, but using visual clues is going to be a piece of that. And then some birds can detect subsonic sounds, which is cool. These are really, really low frequency sounds. They're at 0.05 hertz. The low end of human hearing is something like 20 hertz. So these are very, very low sounds. And because they are such low sounds, the wavelengths of those sound waves are extraordinarily long. So if you can detect them, you can hear something happening a very long distance away, right? So we think that some birds can hear the sound of the ocean reaching the coastline. So even if you can't see that, if you can hear it, you still know where it is. Same thing about sounds echoing off a mountain. And then famously, a lot of songbirds we think can detect approaching thunderstorms from a long, long way away, like in time, and that helps them time when they are going to take off on their journey to take advantage of prevailing winds and make their journey go actually faster. So pretty cool. Olfactory navigation. This is one that, we always thought birds don't really smell very well, right? Well, maybe turkey vultures do. Well, maybe seabirds do. It turns out most birds have a much more well-developed sense of smell than we ever actually thought, and some of them very famously. So homing pigeons can find their way home from a long distance, and we never really knew exactly how they did it. They have magnetite in their bills. They can hear subsonic sounds. They can see, right? But apparently the most important feature of homing pigeons is this sense of smell. They've done experiments with homing pigeons where they will variously cut off the ability of some homing pigeons to smell and cut off the ability of some homing pigeons to detect the magnetic core of the Earth. And in the birds that could smell but couldn't sense the magnetic field, 100% of them were able to navigate home. And when you flip that, it was only about 12% of the birds once you cut off their sense of smell. So we think they're actually building odor maps to get them home. So sense of smell, most important thing for homing pigeons. Seabirds also really rely on that sense of smell. They can smell krill on the open ocean dozens of miles away, so they can find that food in this, what would just look like a desert to the rest of us. But they also have to navigate hundreds of miles away to find their food, and then somehow make it back to a very precise location on a teeny tiny island in a vast open ocean. And they have to do that pretty efficiently because they have some kids that are waiting for them to throw up all that fish they just ate or carry it back to them. So we have discovered that tube noses like albatrosses are also creating odor maps that guide them as they navigate across the ocean. Pretty cool stuff. So let's just take a really quick peek into where we are in migration in Oregon. I'll just keep this simplified and talk about it by guild. So where we live, most of the waterfowl are actually here in the Portland metro area. Most of the waterfowl are migrants in the winter. So they are moving southbound into our area starting in September, really peaking in October and November. And then in the late winter, early spring, they're going to migrate north up to the tundra or maybe well inland to their breeding colonies. So waterfowl migration almost upon us. We don't really have that many migrating raptors here in the metro area. We do have osprey, of course, which come up from the south around March, middle of March, and they will fly back to the south coming up here. September, October. We also have a lot of migrants that fly over us. They breed up north and winter down south of us. Whoops, and that will be happening here in September. A bunch of the wintering bald eagles that we get on Sauvie Island. If you've been out there in January and seen just so many bald eagles, and then you go back out in June and they're not here, it's because most of them flew up north to breed, and they'll be coming back in the early to mid fall. We're right in the middle of shorebird migration. These are one of those guilds of birds that have a really condensed northbound migration. In the spring, they just fly real quick to their breeding grounds, and then they really have a prolonged, extended southbound migration, and we are right in the middle of that one. And then songbirds, all the migrant songbirds all got in here April, May-ish, and they are starting to move out. It's pretty hard to find a black-headed grosbeak anymore. It's pretty hard to find a lazuli bunting. It's pretty hard to find a lot of our breeding summer songbirds that have already started their migration to the south. All right, let's talk just for 2 slides a little bit about how we can all help, right? A lot of us probably plant a lot of native plants in our yards and provide water and great perches and wonderful habitat because we love birds and we want these birds to have a place to rest and feed and refuel on migration. That comes with some responsibility, right? We don't want to draw migrating birds into our yards just to have Fluffy pick them off or have them fly right into our windows or the other hazards that birds can face in the urban landscape. Free-roaming cats kill up to 1 billion birds a year in North America alone. So that is second only to habitat loss. Habitat loss, far and away, the thing that we are most worried about in terms of any kind of species. But free-roaming cats, pretty big threat to migrating birds. Window collisions, almost as many birds die in window collisions. And then artificial light, we talked about. Birds get drawn in to overly lit cities on migration, and they're confused. They can get trapped in light, and then they can wake up in this maze of glass and built buildings and not know what the heck they're doing and fly into a window. So 3 pretty big threats that we're concerned about. And very happily, there are solutions to all of these, as opposed to most of the problems in the world right now. Cats, you can keep them indoors. If you want them to be outdoors, you can build them a catio. There are so many cool catios that can be built that give your kitty a lot of access to the outdoors. And Bird Alliance has all kinds of resources about building catios on our website, so check that out. All kinds of ways to treat your high-risk windows. We've all had it happen, and we probably know which windows are the problems in our homes. So treat those. There are lots of cheap and low-tech ways to do that. There are fancier and more high-tech ways to do that too. Again, tons of information at Bird Alliance if you want some assistance thinking about that. And then we love it when people take this pledge to go lights out during bird migration. So we have an annual, about a month in the spring and a month in the fall when bird migration is peaking, where we ask folks to really reduce that unnecessary outdoor lighting. Think about putting your outdoor lights on motion sensors. Think about getting your lights shielded, just making better choices about our outdoor lighting. This is not obviously just the homeowners issue. Are all those big mega buildings in downtown Portland, we also approach and ask them to go lights out during, oh, look at those mallards, to go lights out during September into October. So talk to me about any of that if you are curious. And that is the end of my slides. And I am here to take any questions. Yeah. Oh.
I wonder, Candace, can you repeat the question back to the microphone? Thank you.
I'll try, yeah.
Just going back to using the magnetic field for navigation. I'm reading about rapid and dramatic changes in the field now. Is that something noticeable in migration patterns as well?
You know, honestly, I don't think our understanding of that is precise enough to answer a question like that. I think we are still in the stage of understanding that it is a big tool in the toolkit, but not precisely how it's working along the path. But that's a super good question. So the question was, with changes in the magnetic field itself under the Earth, is that affecting the way birds are using the magnetic field to navigate? And the answer is we don't know, but it's a really good question. Yeah.
So these migratory birds that migrate long distance on the ocean, not the ones that can do it for 9 days, but do they sleep do they land on the water and sleep at night, or how do they?
Yeah.
And also storms like a hurricane, or how do they?
Isn't that bananas? I know, totally. So the question is, what in the world, how do these seabirds rest? So albatrosses, very famously, there are some species of albatross that don't land ever I mean, don't go to land ever unless they are breeding. And for some of those birds, it might take them several years to get to a breeding age. So they're just out on the open ocean constantly. Yes, they do land on the water. That is predominantly where they rest. So they'll land on the water, they will sleep on the water, they will feed on the water, but they will not approach land unless they are on their breeding colony. You know, some of them will perish, right? Yeah, but they will seek as much shelter as they can. Again, I think there's a question of if birds can approach these approaching storms, can they evade them? And that is where that subsonic sound ability can help birds too. They could use it to aid them in navigation if they can, or in speed, if they can time things to get a good tailwind, but they could also evade a storm if they know it's coming far enough in advance. Yeah, thanks.
I wonder what the percentage of birds that migrate versus birds that don't migrate.
Yeah, so this is complicated, and I'm going to tell you why it's complicated, but I'm going to give you a couple numbers. So 70%, did you ask why or what percent?
Either. I mean,
Okay, yeah.
everything.
Yeah, okay, so what percent of birds migrate versus not migrate, and why, I guess. In North America, we know that about 70% of our bird species are migratory. Now remember, not every population of every species is migratory, right? So most of the species migrate, but some populations within those species are just going to stay put because they live in Portland. And why do they need to leave, right? Of those 70% of migratory species, we had that 80% are nocturnal migrants. So a vast majority of birds migrate. How did that happen? There's two competing theories, whether there was originally, and originally is a dangerous word because it just keeps taking you backwards, but did birds start in their northern home and evolve a migration south to the tropics? Did they start in their southern home in the tropics and evolve a migration northward to breed? There's competing thoughts about that. Our new understanding is that it's probably different for different species. We think that some birds evolved to migrate from being sedentary species in the tropics, and some birds evolved to migrate down to the tropics from northern areas. That's another hot topic, is how did it evolve and why did it happen? If you think about the last glacial period, the Pleistocene age, which is about a 2 million year long period where glaciers were advancing and retreating and advancing and retreating, but they were doing that over long periods of time. That would create some barriers for short movements of birds, so they wouldn't be able to move. And then it would create all these big openings for them to move, and then maybe that would get cut off by a physical barrier, and they would have to stay, and yeah, so crazy story. We don't understand it all. Scientists are definitely still fighting about that question.
How many don't migrate then?
Well, 30% of the species in North America are not migratory. Yeah,
Okay.
ish. These are round numbers.
May I use an odd example? I'm from the Midwest, and we had cardinals year-round, cardinals, and someone got the idea that they wanted cardinals in Hawaii. So there are cardinals, at least on the Big Island, and I think Oahu, I'm not sure all of them, but anyway, but that's such a different environment.
Yeah, and many, that was something that happened in a lot of places when immigration happened to the US. This happened too, right? A lot of birds were brought in from Europe to the US and set free. And there were various reasons for doing this, but one of them is that immigrants wanted a little taste of home, right? Something familiar, so they would bring some bird species. That happens a lot in Hawaii. There's a lot of immigrant bird species there. And some of them did not make it, and some of them thrived. So that is how we have introduced species, is because some birds were able to adapt, and some were not able to adapt. Yeah. Yeah,
Oh, me? Okay.
sure, yeah.
I'm wondering how, of course, I'm sure the scientists are studying climate change now with all the migration
Yeah.
affecting.
Oh, yeah.
birds.
Yeah, it's a tricky one. There's this thing that happens that's really troublesome, which is this mistiming. So birds over, millions of years have evolved migration strategies wherein they get to their breeding grounds at exactly the moment in which they can set up a territory and raise their kids and hatch those babies when food sources are at their peak, right? So this has evolved for a long, long time. And they do that, of course, because that's a very important time to have abundant food resources. So climate change is shifting when those food resources are actually more abundant, right? If things bloom and go to seed earlier, a bird that can't adjust its migration timing because it's cued in by photoperiod might get to its breeding ground after those food resources have already peaked. And that is a problem. So that is something that we definitely worry about. And it takes, evolution is slow. Slower, the sort of bigger and clunkier you are. And so birds will evolve, but just like with plants, it's very hard to evolve fast enough to keep up with something like climate shift, which is happening so quickly. Yeah, and it turns out that shorter distance migrants are better at making those adjustments than longer distance migrants. We don't exactly understand it. It's very hard for a Swainson's thrush down in South America to make any kind of an adjustment on their migration timing. But a bird that's maybe a couple hundred miles away has a better sense, I guess, of the conditions around it, we think, and therefore they are able to make better adjustments in their migration timing.
Is there anything they're doing to mitigate some of the problems, like for long-range birds, like in communities?
I mean, it's pretty tricky. There have been some studies. The question was, is there any way to mitigate for this mistiming that climate change causes birds? There have been some efforts to try and work with local agriculture, local farmers to maybe mow at a more advantageous time or plant at a more advantageous time. There are some things that we can do, but it's obviously limited. And there are obviously huge pieces of habitat that are just disappearing, right? And so now a bird has to change where it goes. And one of the things that we are finding are some very clear correlations between climate shifts and ranges of certain birds. So bird ranges are definitely shifting. Yeah, they're also disappearing. There was a big study that probably a lot of you saw in 2019. It's actually a study that comes out every 3 years. But in 2019, they did a State of the Birds report, this consortium of all kinds of conservation organizations and bird science folks put out a report that showed that we've lost 30% of the bird species in North America in the last 50 years, or 3 billion birds out of the North American breeding population. It's different for different birds. Grassland birds, just tanking, right? The one guild of birds, because grasslands are one of the most susceptible to development, overdevelopment, and climate shifts, the one guild of birds that is going up, does anybody know what it is?
Pigeons?
No, not pigeons. It's a whole group of birds that's doing pretty well across North America.
Sparrows?
It's waterfowl, right? Waterfowl numbers over the past 50 years are actually higher. And this is actually a little bit of a hopeful story for me because what we do for waterfowl is we protect a huge amount of our open spaces for duck hunting and wildlife refuges and all of those space conservations that help waterfowl. So where we invest in habitat is where habitat does well, and the habitat we invest in supports even more birds. So waterfowl are doing better probably because we invest in it. So that's a solution, right? That's a solution right there. It's not an easy solution. It's not like you can just manufacture the political will or the money for that, but there is a way to do this, and that is to invest in the habitat that we need. Yeah.
Well, for those of us who remember the 50s and 60s and having our parents' windshields just completely splattered with bugs, driving just about anywhere
Yeah.
except around town. That's not the case anymore. You can go for a long trip and only get 1 or 2 bugs, maybe. And now, have any studies been done to see if some of the birds are adapting to different food sources? Because that's got to really impact their food supply.
Yeah, that's a really good question. I don't know if I have a direct answer to that. The comment was there's a lot less bugs out there than there used to be. That's got to be impacting the birds. Is there a way that they are adapting to that? You know, as insect populations go down, so does everything that relies on those insect populations. So indeed, the paucity of insects is affecting everything above it on the food chain, including birds. And if you think of a bird like a swallow or a swift or a kingbird or any of these aerial insectivores, that's what they eat. I mean, they are obligate insectivores. They can't, in most cases, really eat much else. So, no. Yeah.
Your picture is really funny because this weekend we were at Canyon Beach and all the nests are filled with baby swallows. It seems
yeah.
so late in the year, and I'm wondering, climate change, are they having more fledglings, more?
It's an interesting question. Yes, for anybody who doesn't know, these are barn swallow kidlets. They are so stinking cute, right? And the thing about barn swallows, it's kind of amazing, and I've noticed this throughout, is they will lay eggs and they will fledge those kids, and the next day practically they are laying eggs again, right? So barn swallows will continue to produce new clutches of barn swallows as long as they possibly can, and really until they're gonna migrate out of here. So yes, it is late for most birds to be. I was just in Manzanita recently and saw the same thing. They're just everywhere.
That's
yeah.
why they help their bird numbers if they're going to have more clutches.
For sure, yeah. I don't know, that's a great question. The question being, are they actually breeding more as a compensation for the risks that they're facing? I don't know if anybody's studying that, but it's a great question. Yeah. Sure. Sherry, did you have a question?
No.
Okay. Sure, I'm looking at you.
Did you know that there are turkey vultures that kind of are home based around Willamette Falls? I'm not sure exactly where, but they come back every year and their numbers seem to be doing really well. I don't know, were you aware of that? Because it's kind of unusual to have turkey vultures around here, but we do, and it's every year.
Yeah, absolutely. Yep, the turkey vultures and the osprey are sort of on the same timetable. One of the little truisms in migration timing is St. Patrick's Day is the time you look for ospreys and turkey vultures returning. So it's a date many people can remember. So mid-March is when those are showing up. And yeah, it's pretty cool. And there's a lot of theories for why turkey vultures are migratory, because they're eating dead things, right? And there's certainly plenty of dead things. They're obligate carrion eaters. There are plenty of dead things in the winter. There's plenty of roadkill, so why do they do that? But what there isn't plenty of at higher latitudes in the winter is daylight or warmth or foraging hours. So it is quite possible that those foraging hours are just too short and the temperatures are just too low for them to effectively feed here year-round. Why we think they go south.
Yeah. I'm curious, so
Maybe next.
we have year-round Anna's hummingbirds. Yeah. Has anybody studied to see if the ones that are year-round residents versus the ones that migrate have a improved breeding success or anything? Or like, there must be an advantage to the ones that migrate. Has anybody looked at?
Yeah, I mean, it's a complicated thing. So Anna's hummingbirds are a really interesting example of a bird that was not in Oregon, 50 years ago. It would be pretty rare to see an Anna's hummingbird. They have had this very kind of quick expansion up from Southern California. And there's a lot of theories for why that is. One of them is that in Southern California and moving up that California coast, a lot of flowering plants started getting planted that was creating this forage that just helped them make this range expansion. One of them is that people are like, let's feed hummingbirds. And so we provide a year-round food source for hummingbirds. There's no great answer for this, but around the year 2000, which isn't very long ago, is really when we started seeing significant numbers of Anna's hummingbirds around here. And now they're one of the more common bird, everybody can identify an Anna's hummingbird in winter. It's the only one here. And so it's pretty cool. So they seem to be doing well. So is your question like, do rufous hummingbirds do better than Anna's hummingbirds in terms of fecundity? Yeah, I don't know specifically for hummingbirds, but I do know overall that is true, that fecundity is higher for migratory species. Of course, many more of those kiddos are going to perish, right? Because migration, how many kids are actually going to make it back to the wintering grounds and then back up to breed? It's not any more than is going to replace the population.
I was wondering if, the cost of staying through the winter to the bird, is
That's interesting.
versus, if it migrates, there's obviously a cost to that, and does it affect their breeding success? I don't know.
Yeah, right. Yeah, it's such a good question. And it's complicated. It's so species dependent, and everybody evolved their own strategy. So I love that question. Yeah, you had a question in the back, and I keep passing it.
Yeah, I know you're over time, so you don't have to go into this in great detail, but you didn't touch on owl species, and I was wondering if most of them, like the barred owl, barn owl, great horned owl, kind of like our common species, stay put, or if they do kind of like global migration.
Yeah, great question. Yeah, most of our owls are resident or sedentary. They are mostly, the barred owl, of course, has a famous range expansion, but that's different than migration. The one owl species that does migrate here in Oregon is burrowing owls. They're fairly short distance, they're not migrating to South America, but they have a pretty interesting and understudied migration where they do this thing called leapfrog migration, where the more southerly breeders, so say a burrowing owl who is breeding in Idaho might migrate to New Mexico. I'm making this up. And then a breeder up here in Canada might migrate all the way down into central Mexico. So they actually, the more northerly breeders migrate to the more southerly wintering spot. A lot of birds actually do this. We don't understand it well.